Question 14. In a process for manufacturing glassware, glass stems are sealed by heating them in a flame. Let X be the temperature in degrees Celsius for a randomly chosen glass. The mean and standard deviation of X are mu of X is 550 degrees Celsius and mu of sigma X is 5.7 degrees Celsius. So we want to know, is the temperature discrete or continuous random variable? So the difference between discrete and continuous is discrete is broken up and continuous is smooth, right? All different values between. Whereas broken up, like if you're counting, number of people at a concert, you can't have a half of a person, so that would be discrete. So temperature is actually continuous. Continuous is, think about measurements, okay? Measurements are continuous. Right, when we're doing measurements like weight and temperature and height and all that stuff, there are values that can go between them. So temperature is going to be continuous. It's a continuous random variable because it takes all values in an interval of numbers, not specific ones, all values. So let's get into how to work with that random variable. So you have a target temperature of 550 degrees Celsius. Again, what are the mean and standard deviation of degrees off target? So if your target is 550 degrees and your mean is 550 degrees, how much are we off target? Well, with that mean, you just say the mean of D is equal to mean of X minus 550 degrees. Well, we know the mean is 550. So we're going to plug 550 in for that. It turns out that if your mean is 550 and your target is also 550, that's actually going to give you a new mean of your degrees off 0. So we are 0 degrees off on average from your mean. Now, the standard deviation that's not going to change because adding and subtracting doesn't change the spread. So that's going to stay 5.7 degrees Celsius. We can just say adding or subtracting does not change the spread. So that's just going to be 5.7. Only multiplying and dividing change the spread. So that gets us into our last question from this particular stem, which is a manager asks for results in degrees Fahrenheit. We're given degrees Celsius. We want to know degrees Fahrenheit. We know we were given a conversion. So that the random variable y is going to be the conversion from degrees Fahrenheit, Celsius degrees Fahrenheit. So it's 9/5 x plus 32. What are the mean and standard deviation of y, the temperature of the flame, in degrees Fahrenheit? So the mean and standard deviation of y, let's start with the mean. Mean of y is going to be, you're just going to plug in the mean of x into there. So you're going to say 9/5 times the mean of x plus 32. And we know that mean is 550. So 9/5 times 550 plus 32, that's going to work out to be (1,022 degrees Fahrenheit). So we got that. So now standard deviation. So standard deviation, like in the previous problem, adding or subtracting doesn't affect that. So for the standard deviation, we ain't doing this. We're only doing multiplying and dividing. Multiplying and division changes spread, but adding and subtracting doesn't. So for the standard deviation of y, we would say only the 9/5 times the standard deviation of x. Don't do that. So we're just going to plug in the 5.7 into here. So it's going to be 9/5 times 5.7, which is 10.26. So our new standard deviation is 10.26 degrees Fahrenheit, which means that on average, the standard deviation is off by about 10.26 degrees from the mean of 1022 degrees Fahrenheit. So adding and subtracting do not affect spread, but multiplying and dividing do. Okay, adding and subtracting do not affect spread, but multiplying and dividing do. Thank you for watching my TED Talk.